Hey guys, today we're starting a new chapter. We're going to be talking about lesson 6-2, and I have had to butcher the title because Canvas won't allow us to have a title more than 51 characters. So a lot of abbreviating going on, but this is the official title that you should be using: Solving a System of Equations, and I'm going to throw in the word linear. Using substitution. So we're basically going to be talking about two strategies, this one and elimination, including elimination with the multiplication. We don't really talk about graphing because graphing's super inaccurate. So let's start off with, what do I mean by a system of linear equations? Now, you can have a system of linear inequalities. In fact, we'll cover that at the end of the chapter. So it's two linear equations written with the same two variables. So both say x and y with the same two variables. With a common solution. So in other words, there's one ordered pair, generally speaking, that is true for both of them. Okay, now we're going to talk about three different types of solutions, and we've kind of talked about this in a different format in an earlier chapter. So the first one is the one we expect to see, and that's one solution. If we graph it on axes, and this is just a rough graph, the lines are just going to intersect in exactly one spot, okay? So that's going to be your solution to both of them. If you substituted back in those coordinates into the equations, you would get exactly, it would work for both of them and make them both true. Okay, now, some words that go with this. Because this is what we expect, it is consistent with our expectations, so consistent, and it is independent. Okay. All right, the next one is getting no solution. So let's see. Can you think of a situation in which two lines can be graphed on the same coordinate axes and they don't intersect with each other? And if you're thinking, the answer is, oh yeah, we talked about that. Would be this situation of parallel lines, okay? So parallel lines, that's not what we expect, okay? So we say this is called inconsistent, not consistent. It's not consistent with our expectation. We expect two lines to intersect with each other, okay? So this is no solution, okay? And then the last one, we kind of talked about this one too, was infinite solutions. Now, you're used to calling something like this all real numbers, but all real numbers are individual values, whereas when we talk about solutions, we're talking about ordered pairs. So let's go back to the first guy. That means there's one ordered pair they have in common. With no solution, there's no ordered pairs. None whatsoever, okay? So you can say no solution. And then let's draw a picture of infinitely many solutions. And that would be the situation of, let's pick out. We'd graph the first guy, and then we'd graph, I'll do it a slightly different color. The second guy. And if you notice, they're right on top of each other. So this is when we have infinite ordered pairs. So we just say infinite solutions. Now, this is consistent because we are expecting our lines to intersect, but the lines are dependent because they have everything in common. So again, big thing to take home, solutions are ordered pairs. So written with the x first and the y second. Boom, boom, boom. And then now let's talk about what we're going to be working on the next page, and that's the idea of substitution. So with substitution, we're going to be replacing a variable with an equivalent value. Now in this case, it's just not going to be a direct exchange with the variable and a number. It's usually going to be an expression, okay? So now the strategies, that we're going to be talking about, this one, substitution, and then elimination, and elimination with multiplication. You got to pick which one is going to work, okay? So it's not like you're always going to do substitution. I know how much you guys like to do things one way. That would be nice if the world worked like that. But what you're going to do is look at what you have. And if you have an equation in your system where it's solved for one variable, then it's set up to use substitution. If none of your variables are alone, then that's when you're going to use this idea called elimination, okay? So let me just kind of write down on the left side, we'll just kind of write down the steps. So first thing you're going to do is you're going to solve one equation for one of its variables. Personally, if I have to do this step, then I don't want to do substitution. What I want is, do I have an equation that's already solved for one of the variables? That's just me. Second step, we're going to substitute the expression. That's what we're going to get when we solve one equation for one of its variables. Found. So that's how we found it from step one, into the equation not used. So you can't substitute it back into itself. That doesn't work. So you have to substitute it into the other equation. Okay. And then you're going to solve for the other variable. Now this is all going to make a lot more sense once we get to the practice. So now what we've done is we figured out half of our ordered pair. How do we get the other half? We're going to substitute this value found for the second variable into so this sounds kind of weird. So substitute the value found for the second variable into the equation found in the first step. Now I'm going to say something else. You can actually substitute it into either original equation, okay? All right, so let's get to some practice. Directions are just going to say, like, solve, okay? So here we go. We've got x minus y equals 1. And we have 3x plus 2y equals 8. So I have two equations written with the same two variables. It's a system. All right, so I get to make a decision who I want to get alone. And what I notice is both x and y don't have coefficients. So they're going to be the easiest ones to get alone. I'm not going to mess with the second equation. All right, so I'm going to take this guy, bink. And let's go ahead, and probably the easiest thing would be to add y to both sides and solve for x. Okay? So what do I do now? All right, well, I'm going to take this equation that I just found right here, this guy, and I'm going to focus just right here on what y plus 1 is. And what am I going to do? I'm going to substitute it in for x in the other equation. So here's what it looks like. So this is basically step 1. Here comes step 2. 3, and then we're going to have times the quantity y plus 1. That's taking the place I'm substituting in for x, plus 2y equals 8. And now I'm just going to solve. So I'm going to distribute, and I get 3y plus 3, so bink, bink, plus 2y equals 8. I'm going to combine up like terms. I get 5y plus 3 equals 8. I'm going to subtract 3 from both sides to get the 5y alone. I'm going to divide both sides by 5, and I get y equals 1. Okay? So what I've just done is I've just figured out half of my solution. So I'm going to kind of mentally put him aside. But I'm going to use him. How? I'm going to substitute him back into, generally speaking, the other equation. So I was substituting this guy. I like to go into the other one. That's the wording they used. That was substitute this value for the second variable into the equation found in the first step. Okay, so I substituted it into the x minus y. It can go either original, but I like to put it back into the other equation I didn't use in the step before. So now I'm going to keep x, and then minus, and then y is going to be the 1. And then equals 1. And then I just solve. I'm going to add 1 to both sides, and I get x equals 2. So now I'm going to take the two coordinates, and I'm going to make an ordered pair out of them. x, y. So if I graphed these two lines, they would cross exactly at the ordered pair 2, 1. And that's the solution. Now, the directions did say, oh, I guess I should write that. I didn't do that. Let me do that. Check your answer. To do that, I'm going to substitute the ordered pair back into both original equations. So let's do that in... Okay, so 2's for x, 1's for y. Does it make a true statement? Well, 2 take away 1 is 1. Yep, it does. So it satisfies, we say it satisfies the first equation. Let's try the second one. 3 times the x value of 2 plus 2 times the x value of 1. Question is that going to equal 8? So 3 times 2 is 6. 2 times 1 is 2. 6 plus 2 is 8. It does, so it satisfies both of them. So that just verifies that we have the right ordered pair. All right, let's do one more. And let's do this one. xy minus 8x, minus 10y equals 10, and x minus 5y equals 20. Okay, so in this equation, I only have one variable that doesn't have a coefficient. So that's what I'm looking for to solve for. Okay, now again, personally, I wouldn't use this strategy in this case. What I would use it for is if I was given 8x minus 10y equals 10 and x equals 5y plus 20. So that work's already done for me, okay? All right, so very simply, we can go ahead, add 5y to both sides. Oh, sorry, I don't want to write that. Plus 5y. And we're going to get x equals 5y plus 20. So we're going to take this 5y plus 20, and we're going to substitute it in for x in the other equation, okay? So that's going to give me 8 times the quantity, 5y plus 20, minus 10y equals 10. So again, if you notice, we're just doing a lot of mathematical gymnastics. So we're going to go ahead and distribute. And 8 times 5y is 40y. And then it says plus 8 times 20. 8 times 2 is 16. And then there's a 0. Minus 10y equals 10. We're going to combine like terms. Whatever math it tells me to do on the side is the math I do. So it's 40y, take away 10y. So that's going to give me 30y plus 160 equals 10. I'm going to subtract 160 from both sides. So what you guys should notice is that the math isn't that challenging, but there's just a lot of it I have to do. Super simple to make calculation errors. That's why it's very important for you guys to test your solution. All right, we got 1. Yes, we have y equals negative 5. So now what I'm going to do is I'm going to substitute that y value into the equation that I had solved for x. Why? Because I haven't used it. All right, so that's going to give me x minus 5 times negative 5 equals 20. And then we're just going to keep solving. So I get x, two negatives make a positive, 25 equals that, and then I subtract 25 from both sides, and we get x equals negative 5. So, putting in order, x first, y, is that weird? I got the same number twice. Okay, so we're going to check both equations. 8 times negative 5 minus 10 times negative 5. Does that give me 10? So let's see, I get negative 40, 2 negatives make a positive. I get a 50. And I get 10 equals 10. So it satisfies the top equation. Now let's try the second one. Negative 5 minus 5 times negative 5. Does that equal 20? So let's see, I get negative 5. 2 negatives make a positive. 5 times 5 is 25. Negative 5 plus 25 is 20. And it's true. So that means it satisfies the equation. So in other words, I agree that the answer for this system, where they will intersect, would be at the point negative 5, negative 5. All right, that's what I got for you today. Good luck, guys. Bye now.